Hello everyone, welcome to my channel. Today we'll be discussing a new chapter 11, nucleophilic substitution of carbonyl with loss of oxygen. Now we'll be discussing some important problems from this chapter. Okay, so the first problem is this one. There is an ester group and there is a ketone group. On reaction with hydrogen, this product is going to form. Now let's see the mechanism behind this. Firstly, we know that aldehyde and ketones are more reactive as compared to the ester group. Okay, so the lone pair in the nitrogen atom is going to attack in the carbonyl carbon and thus forms, it becomes O minus, and this minus charge is again going to abstract a proton. Okay, and thus forms OH, and similarly one hydrogen will be lost here, so NH2. OMe. Again, the lone pair in the oxygen atom will abstract this hydrogen atom. Okay, and thus there is a bond, and this bond will go there, and thus it gets leave. Okay, thus giving an imine system. Okay, immune system. Now what is the next step? The next step is, since there is a possibility of formation of 5-membered ring, 1 2 3 4 5. Okay, so the lone pair in the nitrogen atom is going to attack in the carbonyl carbon here, and the charge will go to the oxygen atom, and again it will come back since there is a leaving group, so this is going to leave. Okay, thus giving us there is one more hydrogen atom, right? But this hydrogen atom will leave. Okay, now you may think this should be the product. Why the product is not matching? Because since this product forms after when it undergoes an equilibrium and negative charge is formed here, again this negative charge which is formed here will abstract this hydrogen atom, thus we get the product. The reason behind this is because there is a possibility of conjugation here. Okay, there is a possibility of conjugation, right? So it makes it more stable, so this is the final product. Okay, now let's move to another example. In this question, from aldehyde to dithioacetal formation. So for the aldehyde, it acts as a protecting group. Now how this forms, I will show you the mechanism behind it. Okay, firstly the lone pair in the sulfur is going to attack the carbonyl carbon, and negative charge is going to be in the oxygen atom. Okay, then this negative charge which will be in the oxygen atom will again abstract proton from this. Okay, this will abstract this proton and thus forms OH by abstracting the proton, and it becomes SH, right? Further, now since HCl is given in the reaction, so I'm writing here HCl means H plus is providing, in presence of HCl means acid is providing H plus ion, so this OH minus ion will abstract this H plus, and what it will form? OH2 plus. Okay, and here SH. Okay, then what will be the next step? Again, since now OH2 is a good leaving group, OH is not a good leaving group but OH2 is, so the lone pair in the sulfur atom will now attack here in this carbon, and the OH2 will leave. Okay, thus giving us the product as hydrogen. You might be thinking, what is the hydrogen? This will again leave. Okay, so this will give the product like this. Now let's move to another example. Okay, this is a 1 degree amine, 1 degree amine, and the final product is 2 degree amine, right? So I will show the mechanism from 1 degree amine to the formation of this product, which is 2 degree amine. Firstly, what it has been given in the question, reaction of amine with aldehyde. Okay, let's do. The lone pair on the nitrogen atom is going to attack first on the carbonyl carbon. See, we have done in the previous example with hydrazine with the carbonyl compound. Okay, so I will not do the same mechanism again. Instead, I want to show you that when there is a amine system, there is hydrogen, two hydrogen, and when it attacks with the carbonyl group, then this two hydrogen will react with the oxygen atom. Okay, thus water is eliminated. You can think like this. Okay, and thus what it gives, and this is left, and this, since there is a double bond, right? So double bond will come like this, and it is attached with pH and a hydrogen. Clear? Okay, then what is, so this is the product in this step. Next, on reaction with NaBH4, that is, it is a hydride donor. Okay, I can write it like this, NaHBH3 minus. Okay, don't think minus is going to attack here. It is hydride donor. This is a hydride donor, so hydride is going to attack. Where it will attack? It will attack where it is, where delta is plus here, and here is delta minus. More electronegative, here electronegativity is less, so it is going to attack here. Okay, then negative charge will come on the nitrogen atom. Further, this negative charge will again abstract a proton. Okay, thus giving us our product as NH carbon pH, giving us second degree amine. Okay, clear? This is the final product of this reaction.